how power works within a laptop motherboard. Okay, so let's get started. So here we have adapter or charger. Okay, and this is the charge IC or the control IC that manage the charge for the battery and also the input voltage. Okay, so this is basically the direction of the power. The 19 volt, as you can see here, will be applied to all circuits or to all controllers in the motherboard. This is the first controller. As you can see here, we have 19 volt is applied. Here we have the second controller. This is the third controller and the fourth controller. So this controller basically has the purpose of generating these voltages. Okay, the always voltages means the 3 volt always and 5 volt always. Please don't forget to subscribe, share and like the video, please, because your likes really motivate me to create more videos for you. And for anyone who wants to accelerate learning, you can join me in my Patreon page and I can be your mentor. All links in the description. And welcome to your comments and questions. I always do my best to answer all comments. So let's get started. 3 volt, 5 volt circuit. Always look for the ceramic capacitors. Okay, here we have ceramic capacitors for this channel. Over here we have other ceramic capacitors for this channel. If we check those capacitors, we have to find 19 volt, as you can see. Okay? For this channel, the 5 volt channel. Okay? And if we check those capacitors here, we have also to find 19 volt. Let's check this side. As you can see, we have 19 volt for the 3.3 volt channel. So 19 volt will pass through these ceramic capacitors, as you can see here, in order to be filtered, and it will go directly to the MOSFET here. We have the drain over here. Okay, why this is drain? Because we have this dot. This is the source. So, and over here we have the gate. If we check the gate, we have to find 5 volts. As you can see, why? Because we want to get 5 volt here. Okay, so we have here 19 volts and we have here in the gate 5 volt. So we will get 5 volt in the source. The same for this channel. The 19 volt will pass here through these ceramic capacitors in order to be filtered and then goes through these voltage regulators. Here we have the dot over here, means this is the gate. We have to find 3.3 volt. Why? Because we want to get 3.3 volt here. Okay, so 19 volt in the drain, we have the gate is activated 3.3 volt, so we will get here 3.3 volt. Okay, so, and of course the test point for every channel is inductors. This is the 5 volt channel here. Okay, also if we check this capacitor, we have 5 volt, and over here we have the 3 volt channel, as you can see, in the capacitor, in the inductor. Over here we have the RAM. The type of the RAM is DDR3, means the working voltage is 1.5 volt. So we have to find 1.5 volt here. As you can see, we have 1.5 volt in the inductor next to the RAM. The same voltage that we have here, as you can see, we have it here in this ceramic capacitor. So this ceramic capacitor feeds the RAM chip. If you have any problem with the RAM voltage, try to check these two capacitors. This capacitor for VTT and this capacitor for the working voltage. Okay, and of course here we have to find 19 volt that pass from here to here. But for the RAM circuit you have to check resistors. Do you see here? We have resistors. If we check this one, for example, we have 19 volt. Okay, 19 volt that comes from the charge circuit and pass through the 3-volt 5-volt circuit, and we find it here in the RAM circuit. The same thing for the processor circuit. So for the processor, the same thing. We have to find the main voltage, 19 volts. So let's check if we have MOSFETs. Always look for MOSFETs like this or like these small MOSFETs, okay? So we don't have MOSFETs here. Let's see the other side. So this is the back of the processor. We have the IC, the CPU control, and we have these two MOSFETs. If we check these two MOSFETs, we have 19 volt, as you can see. So this is good for the main voltage for the processor. Now let's see the other side and check the VCC core and VCCP. So this is the MOSFET. The MOSFET, usually the MOSFET always have more than one channel, okay? So if we check this inductor here, we have 0.8 volts. So this is the VCC core, because always the VCC core is between 0.7 volt to 1.5 volt, okay? And here we have other inductor. So this one, basically this is 0.05 volt to feed the BCH, okay? And we have another voltage here, 0.5 volt or 0.03 volt. This is basically the VCCP, okay? The voltage for termination or for communication between the processor and the BCH. Do you see this part here? So without this voltage, the communication will not occur between the BCH and the processor. This circuit is 3 volt 5 volt circuit. Here we have the 5 volt channel. If we check this inductor, we have 5 volt in the multimeter, and this is the 3.3 volt channel. This inductor, we gonna find 3.3 volt. So for every channel we have inductor, capacitor, inductor, capacitor, and of course we have the IC, the 3 volt 5 volt IC. You can measure 5 volt in the inductor or capacitor or test point. The same for 3.3 volt channel. You can measure 3 volt here in the inductor or in the positive terminal of the capacitor, or of course here we have the test point. This is the controller IC PU1000. We have inductor PL47, PC1014. This is for 5 volt always, and for 3 volt always we have PL46 and PC1011. For those MOSFETs, we gonna find it in the back of the motherboard. For 5 volt channel, we have PQ97 and PQ99. Do you see here? We have B plus is connected to the drain of PQ97. So here we gonna find 19 volts. So let's check. We have PQ97. We have this dot here, means this is the pin number 1, pin number 2, and pin number 3. So these 3 terminals and source. Here we have the gate, and over here we have the drain. So let's check 19 volt in the drain. So if we check the pin number 5, we have 19 volt. Pin number 6, 19 volt. Pin number 7, and pin number 8. So the main voltage 19 volt is present. So here we should find 5 volts, as you can see, and also in the drain of PQ99 we have 5 volt, and these terminals are connected to the ground. How we can use power state to detect and troubleshoot quickly and easily any problem within a motherboard. We have S0, S3, S5. So I told you before that S5 means soft off, means the laptop is totally off. S4 we have suspend to disk, means almost the 5 volt is generated and the disks within the computer, I mean the hard disk drive and the ODD or the optical disk drive are on. S3 we have suspend to RAM, means the RAM is almost on. Means what exactly? Do you see here we have S3 here? So we have here 2 voltage. This is the voltage for the RAM, because for the memory or random access memory it has always 2 voltages. One main voltage, in this case the main voltage is 1.2 volt, because the kind of memory in this laptop is DDR4. We have 1.2 volt, and the voltage for terminal we have DDR VTT, means the voltage for terminal, the half of 1.2 volt means 0.6 volt. Do you see here we have the main voltage we have on, but the voltage for terminals we have off. So in S3 the RAM is almost powered on. Okay, and then we have S0 where all voltages, all these voltages are present. So in S5, of course, when the AC is inserted, we have these voltages, including 3.3 volt and 5 volt always. If you test the motherboard, you will find all these voltages. Okay, but in S0, for example, you will find all voltages are present, including VCC core, the voltage for the CPU. So let's, for example, assume that we have a problem. You turn off your laptop or your computer, so the computer is totally off. Nothing happened. Now LED is on. Nothing happened, means the motherboard is dead. So in this case, let's use the states to detect the problem. We have the problem, of course, is in state S5. We cannot go and check, for example, the VCC core. Here we have S0, all voltages are present. S0 means all voltages are present. But for us, the computer is totally off, means we have problem here. Okay, if you insert the adapter, because when the adapter, as you can see, doesn't exist, these voltages also will be off. But when the adapter is inserted, these voltages should be present. So if the laptop is totally off, means we have problem here. We don't have 3.3 volt, we don't have 5 volt, means the problem could be with 19 volt. We should check 19 volt. Don't waste your time and look for the VCC core, the DDR VTT plus 3.3 volt. Don't waste your time. Go and check the main voltage, 19 volt, because the laptop is totally off. But another issue, let's assume that you press the power button, the laptop comes on, the LEDs are on, the fan or start turning, the fan is working, 3 seconds, the laptop goes off. Here, what could be the failure? So the failure will not be here. Why? Because here we have S5. Those voltages are always present in S5, means without powering on the laptop. It could be, the problem could be in S3 or in S0, but because the laptop is turning on for 3 seconds, the fan is working, the problem is here, will be here. Check these voltages. The problem could be with the processor. We have plus VCC core in S0, and we have the DDR or the voltage for terminal. So in this case, you should go, based on my experience, in this case, you should go and check the CPU circuit. If you check the CPU circuit, 100% you will find the problem within a MOSFET or the control IC for the CPU. Hi, so welcome again. So this is a very important video where you're going to understand a great thing about the power state, as you can see here, and the power management table. So this is basically also one of the most important and very exclusive unique videos in my channel. So this video basically will let you know all about the power states in the laptop or computer. So, and if you know, of course, about the power states and the power management within the motherboard, you can figure out the issue or the problem any motherboard very quickly and easily without wasting time. So let's get started. So we're gonna see basically the states. Here we have S0, S3, S4, S5. I'm going to teach you what is exactly the difference between these states and how we can use these states to troubleshoot and isolate the failure in any motherboard or laptop. And of course we're gonna study all power rails in a laptop, including the 5 volt always, the 3.3 volt always, the RTC or real-time clock voltage, the RAM voltage, the CPU voltage, etc. I'm going also to teach you what is exactly the states and why we use it in the laptop. So let's get started, but please don't forget to like the video because your likes really motivate me to create more unique videos for you in a daily basis. And don't forget to subscribe and hit the bell icon because I can only help you and teach you if you are subscribed in my channel, and of course be notified for future videos. And finally, join me in my Patreon page if you want to download for free this schematic and other many schematics, and of course to enjoy more unique content. So let's dive in. So let's begin here with this table. So we have here, as you can see, S5. Do you see here S5? So S5 here, when the AC doesn't exist, all powers in the motherboard will be off. You will not find any power, including 3 volt always and 5 volt always. So when the AC adapter is removed, this power, as you can see, the always powers including 3.3 volt and 5 volt always will not be present. So these two powers, the 3 volt and 5 volt always, will be present just when you plug the AC adapter, but when the battery is plugged, no power. So we have another case. We have S5, as you can see, with the AC adapter is inserted. Here we have on. All these voltages will be on. We have plus 5 volt always, 3.3 volt always. We have another 3.3 volt always for the disk, for the switch, for the power switch, and please 3.3 volt always for the PCH. This is basically the ICH integrated with the graphic card. We have real-time clock, the 3.3 volt, 1.8 volt, the primary 1.8 volt. We have all 1 volt. We have also 1 volt for the primary core, etc. Okay, but those voltage are not exist in S3. So basically S5, so for S5 means the laptop or the computer is totally off. We called it soft off, as we have here. So for S5 the computer is totally off. Okay, so for S3 we have suspend to RAM. S4 suspend to disk. Here suspend to RAM means the power for the RAM is almost generated. So because if we go here, for example, we have S3, okay? So we have two voltages for the RAM. We have this voltage, 1.2 volt, because here we have the kind of RAM here is DDR4. This is the first voltage, and over here we have the second voltage for the VDD RAM terminals. Do you see? In S3, the working voltage, we have memory, 1.2 volt for memory is on in S3, okay? But the voltage for terminal, or the secondary voltage, as you can see, we have here DDR VDD voltage for terminal, we have here off, as you can see. Do you see? We have off. So in S3 we have suspend to RAM, almost the RAM is working. And we have S4 suspend to disk, means the hard disk drive. And we have, as you can see here, S0 means fall on, means the computer is on totally, 100%, okay? So in S0, as you can see here, for example, S0, as you can see, we have on. All these voltages are present. All these voltages are present. So before going and teaching you what is the importance of these states in terms of troubleshooting and isolation, fault isolation, of course, let's first see the voltages that is generated in S3 and S0. So for S3 we have plus 3.3 volts. This is basically a secondary voltage, it's not always. We have 1.2 volts, we have 2.5 volt. This is basically for memory and graphic card, and we have 1 volt, as you can see, VCC. This is basically for chipsets. Here also, because for chipsets also there are many voltages, it's not just 1 volt, one voltage. Here, for example, in S0, as you can see, if we go ahead, the last voltages that are generated are, we have the DDR for VTT, as you can see, and we have the VCC core, as you can see. You see, we have VCC core and VCC for the graphic card, etc. So now let's basically ask you a question. How can we use these states in order to know exactly, let's go back to our slide. So how can we use these states to know what is the problem within motherboard? So let's assume, for example, that when you press the laptop, okay, you press the power button of the laptop, so the laptop comes on, the fan works, so the fan for the processor works and then stop working. Here, what is the problem here, for example? What is the problem and how can you analyze this failure? So the laptop comes on, the fan so is working, about 3 seconds the laptop become off again. So the laptop also another time is on, the fan turning on, about 3 seconds, 4 seconds the laptop will be off automatically. Here, what is this kind of failure and how we can use these states to figure out the problem? So because the laptop are on, the fan is working and 3 seconds pass, means the S5, the problem is not in S5, because about the basically the time between one state to another state is less than 1 second. It could be a half of 1 second, okay? and sometimes it could be 1 second or more, depending on the type of the computers. So once we have this kind of issue, means the problem is not in S5, means we have to skip these voltages. The problem in this time is not in plus 3.3 volt, is not in 5 volt, is not in these voltages. It could be here in S3, okay, or S0, but because, for example, the laptop is on for 3 seconds, the problem is here. So the problem is here. So we should check the VTT for the memory, for example, and we should check the core or the CPU circuit. And we're gonna see all this circuit, as you can see here. If you understand basically this circuit over here or control IC, you can understand any motherboard. So those square here, as you can see, means circuit of the motherboard. So basically any motherboard contain many circuits. Is, for example, the CPU circuit, the 3 volt 5 volt circuit, the RAM circuit, the NOT bridge circuit, the charge IC circuit, etc. So I'm going to teach you the different voltages in every computer motherboard. If you follow me until the end of this video, I guarantee for you that you will understand any computer power rails. So let's get started. As you can see here, so let's begin, for example, with 5 volt 3.3 volt. So this is two main voltages that you can find in every motherboard. So without these two voltages, the motherboard cannot be operated and working correctly, because all voltages in the motherboard are based on these two voltages, 5 volt 3.3 volt and the 19 volt, the main voltage. Okay, so here basically this is the 3 volt 5 volt controller or IC. Here in the left we have inputs, okay, and in the right over here we have outputs. So in order to generate, as you can see here, plus 5 volt always and plus 3 volt always, we call it always because these two voltages are always exist in the motherboard. Without pressing the power button, you should find these two motherboards. Once you connect the power adapter, these two voltages should be present without pressing the power button. Okay, that's why we called it always, plus 5 volt always and plus 3 volt always. And sometimes we find in some computers or laptops plus 12 volt always. So here we have input and here we have the output. Okay, basically the part number for this IC, the control IC, is TPS 51125. Okay, so here we have the DC bat out. As you can see, this is the VIN, basically the voltage, the input voltage, and over here we have two enable signals. Okay, we have here an enable signal, as you can see here, power S5 enable. Do you see S5 stage? Here we have S5, means S5 means the laptop is the first stage of powering on the laptop. Okay, so here we have an enable signal that is generated in S5 state. Okay, so here these two are input signals. As you can see here, we have input signals. Okay, as you can see, this is the first input signal and this is the second input power. Here input signal because enable, and here input power, we have the input voltage. Then here we have output. As you can see, we have the first output signal. We will get, as you can see, the power good once this input are correct. So we have the power good. Okay, the power good means all powers are connected or all signals are present. And over here we have the output power. We will get then the V out 1 and V out 2, plus 5 volt always and plus 3 volt always. Okay, 6A means 6 amps. Okay, so that's it. Here we have inputs, and over here we have outputs. Okay, I'm going to teach you or to explain to you in a schematic in detail. Okay, in the circuit diagram of 3 volt 5 volt circuit in detail. So let's now see the second circuit. Here we have, as you can see, the CPU core. Okay, the CPU core basically is for the processor. Its reference or part number is ISL6265. Okay, so if you want the details, for example, of this circuit, you can just go to Google and post and write ISL6265, and you will find the circuit diagram in detail of this circuit. So I show you how. So let's go, for example, to Google. We have here ISL6265. Okay, so let's type in here ISL6265. Okay, datasheet, and press enter. So here let's pick, for example, the first result. We have here ISL datasheet download. Okay, this is the same circuit, so let's hit the first result. Here we go. So here basically this is a very important website that I use frequently, alldatasheet.com, because I find sometimes I want to study and to see the block diagram or the circuit diagram of a circuit, so I use frequently this website. This is a very interesting website. So here, as you can see, I have here ISL6265. I have here a PDF file. Here we have 24p, means 24 page. Here, as you can see, we have multi-output controller with integrated MOSFET drivers for EMD SVI capable. So let's click in the PDF file in order to download it, and then here, as you can see, we have download. Let's click just over the part number ISL6265 once again. So here we go. We have here ISL6265 file is ready. As you can see here, we have 24 pages. Okay, one of 24 pages. So you can just simply click over here if you want to download it to your desktop. So let's download it, as you can see. So here we have a security code that we can enter. So let's enter the security code. So 51677, and just click download. So as you can see here, we download right now the PDF file. So the PDF file is downloaded, as you can see, done. So let's click over it. So you can do this for any integrated circuit or any components that you find in the motherboard. If you want to read about it and to know about it more, characteristics and its schematic, its block diagram, etc. So this is the first page. As you can see, you can read the features, etc. So let's move on, for example, to the second page. As you can see here, we have the pinout. Okay, the pinout over here. Okay, so let's see, we have the functional block diagram, as you can see inside the IC. Basically, this block diagram or functional block diagram, you cannot find it in the schematic of the laptop. No, you cannot find it in the schematic, but in its datasheet you will find this functional block diagram, as you can see. Okay, and of course we have electrical specifications, as you can see, including the enabled signals, how much, the temperature, the power, the maximum power. So all conditions you will find the minimum and maximum values, as you can see. Let's go back to our schematic. So we have seen the datasheet of this IC. You can do the same thing for any IC here. You can just pick or take the part number of the IC and then go to Google, post it, and check for its datasheet. So here, using the same working principle, here, as you can see, we have input stage. Here we have input, and over here we have the output stage. Okay, so basically this IC is for what? Is for the CPU. Okay, so here we have the VID setting. the VID setting, we have the input signal. Basically here we have an enable signal. So guys, enable signal means without it means a control signal. It's like a key of the door. Without it you cannot go in. Okay, so for the CPU, of course, it needs 19 volt power. As you can see here, we have 19 volt. As you can see over here, we have the input voltage 19 volt, and it needs also some identification IDs. Okay, so every processor or CPU has its own identification IDs. As you can see here, we have, as you can see, so this is identification IDs. So based on these IDs, the control IC can know the value of the power or of the vehicle that will generate. Okay, because there are some CPU that is powered with 1 volt, others for example with 1.2 volt, others 0.7 volt. But what is the thing that will determine or identify the right voltage? The IDs. The IDs of CPU. So this IDs is sent to this IC from the CPU. So from the CPU to the IC. Then this IC, after receiving these IDs and enable signals, it will then generate the plus VCC core. Here we have plus VCC core 0 and plus VCC core 1. So it means this IC has 2 channels. Okay, 2 channels, because as you know, for the CPU circuit it has more than 1 channel. I will explain to you what does it mean channel, okay, in the next lecture. And also it will generate plus VDD NB, means for the NOT bridge, for the chipset near to the CPU. Okay, so here we have inputs and here we have outputs. So let's move on to the next IC. As you can see here, so the next IC, as you can see here, we have the charge IC, or the control IC that will be charged to generate the voltage to charge the battery and to power the motherboard in the same time. Okay, so here of course always we have inputs over here. As you can see here, we have input signal. Okay, we have input signal here. Okay, and we have input power. Of course, for any IC it needs enables signals. Here we have enable signal, and here we have plus 3 volt, and the AD plus means what? Means adapter. We have DC in here. This IC should receive it the 19 volts. After receiving the 19 volt and this enable signal, it will then generate, as you can see, the V out, DC bat out, means the voltage to charge the battery. And over here we have the input or the adapter. Okay, for the adapter. Okay, so let's move on to the next IC. So here we have plus 1.1 volt for chip, means for chipset, including NOT bridge, including graphic card, including ICH or input output controller hub. So here, as you can see, we have also enable signal. Always we have here input signal and we have input power. So this IC take just plus 5 volt always. Okay, do you see 5 volt always? So that's why I told you that 5 volt always is a very important voltage. So this 5 volt always is the voltage generated by this IC. So this voltage goes directly here. Here this voltage is the output and here is the input. So this IC takes this voltage, and then after receiving the enable signal, here we have S3. So this voltage is generated in the state 3. The power rails within a computer or a laptop, we gonna see the active states, we gonna see the description and the control signal. So as we have here in this table, so we have, for example, the VN or the input voltage. Okay, so the VN is always active in S0, S3, S5, S4 and S5 state. Please, the states are very important approach to any technician who want to excel in this industry. Okay, if you want basically to be a professional in laptop motherboards or computer motherboard repairing, you should know about these states. Okay, so I will put for you the whole video where I speak just about these states in the description box. Please watch that video if you want to know about the laptop states, because without understanding these states you cannot understand how the computer works. So in this video I will not explain to you the states, because I will put for you the video in the description box. The first power signal that we gonna know is the VN, or the input voltage. This is of course the main voltage, about 19 volt, 20 volt, 18 volt, depending on the type of the computer. Okay, so this voltage basically is active. Active means present. This voltage is present in all states for the motherboard. Okay, so for S0, S3, S4 and S5. Okay, so the description, of course, EC adapter, we have 19 volts. Okay, we don't have any control signal for this kind of voltage. It is a basic or a primary voltage. Then we have the main battery. Basically this one also is generated based on VN. This is main battery. As you can see here, we have main battery about usually 12 volt. Here we have 10 to 17 volt. Okay, so this is basically the main battery, means the voltage generated by the battery if the VN or the adapter is not inserted. Okay, the same in all states you can find this voltage. Then we have the VCC RTC. Basically VCC RTC. RTC means real-time clock. Here for this voltage, basically it is the voltage generated by the CMOS battery. Okay, about 3.3 volt. As we have here, RTC or real-time clock, keyboard control power 3.3 volts. Because we have here the keyboard power is powered by 3.3 volts. Okay, and we have plus 15 volt. Of course, this voltage you cannot find in all motherboards. In some motherboard we have plus 15 volts. Okay, in some we don't have, but the majority of motherboard we don't have plus 15 volt as a main voltage also. And we have the CPU core, or the voltage for the CPU. Okay, as we have seen in the previous videos, for the CPU the voltage is usually between 0.7 volt and 1.2 volt, depending on the type of the CPU. And we have seen also that every CPU has its own IDs, and based on that IDs, the control IC for the CPU know the exact voltage that have to generate for the CPU or the processor. Okay, so this basically is active in S0. S0 means the laptop is on. Okay, so please go to the description box, watch the video about states, laptop states, and come back and watch this video. This is an advice if you want to understand 90%. Okay, so CPU core, we have CPU core power, as you can see, 1.25, 1.15, as I told you. They say between 0.7 volt to 1.2 volt. Here we have 1.25. okay, almost. And we have the control signal, we called it VROM. The control signal here means an enable signal or a control signal that without this or those control signals we cannot get this voltage. This is basically an input. Okay, then we have 1.05 volt. This voltage also is for the processor and for the NOR bridge, but this voltage is especially to feed the bus between the CPU and the NOT bridge. We have here FSB, means front side bus. Okay, front side bus. Basically, the front side bus is the bus that connects between the processor and the NOT bridge. Please let me see if I have here the block diagram and see whether we have FSB or not. So we have the processor, we have basically the NOT bridge. This is the FSB. Do you see? We have FSB, front side bus. Okay, we have 667, 800 megahertz. The speed is increased here. So we have FSB. This is FSB. So without 1.05 volt, the data will not transferred here. Okay, means that voltage is the voltage that carry the data to pass between here and here, and of course in bidirectional. Okay, so we have FSB, as you can see, FSB power 1.05 volt. So means if we have this voltage, the CPU core is present. For example, 1.15 volt is present for the CPU. Okay, and also the power for the chipset for the NOT bridge is present, but we don't have this voltage. Means what? Please in the comment below. Okay, so if we have the voltage for the CPU is present and the voltage for the NOT bridge is present, means we have this voltage, but we don't have this voltage that feeds this bus. What do you understand here? Please answer in the comment below. So then we have 1.05 VM. Okay, so this basically here we have the same voltage, but here the only difference here is the type of signal, exactly the amount of current in every voltage. This one is used to feed FSB and this one is used to feed other circuit. And we have here, as you can see, this is the control signal, IEMT on. This is the control signal. We're gonna go and see exactly what is this kind of signal in the next slides. Okay, then we have plus 3 volts that is present in S0 state. This is the control signal. We have 3 volt SAS present in S0 and S3. Do you see 3 volt, 3 volt, 3 volt, 3 volt also here? So you can ask, and what is the difference? Why we use many kind of 3 volt? Here, of course, these 3 volts are not the same in terms of current. Okay, you can find, for example, 0.5 milliamps here, 0.9 here, 1 milli, etc. Okay, and of course here also we have the control signal is different. The control signal for this 3 volt is, as you can see, main D. For this one we have SAS on. For this one we have S5 on, etc. So please don't be panic. I will go with you step by step until you understand everything about schematics. So basically we're gonna see many schematics for many laptops. So my goal here and my objective is to know the process and the right process, and to be methodical and logical in terms of analyzing, troubleshooting, and addressing the issue within a motherboard. I don't like to work in any motherboard randomly. No, for me, I don't work randomly. When I get the motherboard, I try to make a visual inspection about 30 seconds, and then I go and I have the process to follow, and I detect the failure in two minutes maximum. I told you before, 2 minutes maximum. You can give me any motherboard, any kind of motherboard. I'm sure I told you the truth. I repair over than 1,000 laptop. Over than 1,000 laptop. I repair it without any problem. Okay, so that's why I gained this experience troubleshooting quickly the motherboard. Here basically just 3 volts, as you can see here, for state. This one 3 volt SAS is present in S4 and S3, 3 volt S5 present in S0, S3, S4, etc. Okay, so as I told you before, for 3 volts there is a difference in terms of current and the control signal. Here we have also 5 volt, the same for 5 volts. We have 5 volt, but the goal or the purpose is different. This 3 volt, for example, will feed the USB connectors. This 3 volt will feed the hard disk drive motor. This 3 volt, for example, will feed the other parts in the motherboard. Okay, we have here plus 1.5 volts. The control signal is the main D. We're gonna understand this control signals in the next slide. We have 1.5 VM. Okay, the control signal. This is the control signal, the same as we have here for 3 volts. Okay, then 1.8 volts SAS. This is basically for the memory. We have DDR core power. The control signal is SAS. Without this control signal, this voltage will not be generated. 2.5 volts. This is the control signal. SMDDR voltage for terminals. Okay, voltage for terminals will be the half of 1.8 volt, means 0.9 volt. This is basically the control signal. We have DDR command and control pull up power. So this is the DRV reference. Okay, because in every controller and every circuit or control IC, it generates the voltages, output voltages, based on some references. We called it reference signals. Okay, the same, for example, as if you have a reference manual that you use to do a job. The same for the IC. It has some reference signals that always should relate to that reference signals to generate an accurate and exact output voltage. Okay, so we have here, as you can see, the VDDA means basically for audio. Okay, we have audio analog power, 5 volts. Okay, this is the control signal, main on. So when you find, for example, the same control signal for here, main on here, main on, always you have S0 state, because each control signal is present in a specific state. Then we have plus 3 volt for clock, plus 3 volt for LAN. As you can see here, this is the control signal. Okay, 1.25 volts present in state 0 control signal, H0. Okay, so I hope that you understand a little bit about the power signals. So please, if you have any question or any suggestion, or if you want to add something else, please in the comment below. And of course, in the next video, as I told you before, we're gonna discuss, of course, the power sequence. It will be one of the most important videos, of course. The power sequence, please don't miss out this power sequence video, because by understanding this power sequence, you can know the HIC and the role of HIC and how basically the blueprint of the motherboard, how the ICs are positioned in the motherboard, and how voltages and generated. Okay, so tomorrow we're gonna study basically this power sequence or power block diagram. So thank you very much, and please don't forget to subscribe, like and share the video. So see you tomorrow with another video.